So let me share my screen. So I guess as a first, just call out, like, there were all these prerequisites. At some point there were a couple of changes. For example, like, there was a realized last minute that you do need to install Java if you don't have it ahead of time, just because we're going to be working on Spark today. So cool. Yeah. So let's start. So what is Feast? So today, I think the goal of the workshop is to walk through kind of example by example to build up towards what the topic of the workshop is, right? Which is how do you build real-time ML features within Feast? So, and kind of combine that with a Spark and Kafka. But before we kind of get started there, I wanted to make sure that we're all on the same page in terms of terminology. And so here you can see kind of a super high-level diagram of what Feast is. Feast is a feature store. And different feature stores have different definitions. Feast in particular is really focused on a couple of key challenges. So focused on feature reuse within teams. That I think people have heard a bunch. Complex point-in-time correct joins. That's also, I think, like a pretty standard kind of value prop, which is you can have a bunch of data in a bunch of different areas, and having kind of all the features at the right time so that you're not leaking features from the future. That's something that Feast will solve for you as well. But I think the most interesting case is actually this third one, which is how do you operationalize features for online inference in a way that minimizes training and serving skew. And that's kind of really the heart of this interaction between data scientists who then who build their models and then pass their features over to some engineer who then has to reconstruct that feature. So that's kind of one of the core things that Feast is really aiming to solve. And so, a couple caveats. I don't have an M1 Mac, so I couldn't test this. There is a GitHub issue with some instructions on how to develop and run in it. Should be pretty quick. And you will need an AWS account for primarily the first module. And sorry, the main reason why we need it is because we're going to be working with some CI/CD pipelines. So I would recommend that you also fork this repository so that you can actually be running kind of your own pull requests against your feature repo that you'll be working with. So kind of a quick breakdown of the three modules. I'm not sure I'll have time to get into the third one, although I'm hopeful. First one, we're going to start with a general overview of Feast. How do you kind of power batch predictions? So in other words, like, you're not kind of online yet. You're trying to pre-compute a bunch of predictions, but you're setting up the project so that people can share functionality. Let me just look at there's a to make sure that just make sure that the Zoom chat has all questions answered. So we're going to first focus on the case without online, because the online case complicates the problem a little bit. And then the second module is going to focus on that kind of how do you deal with real-time inference, how do you ingest streaming data, how do you do transformations. And then the final module is kind of a concept that's more unique, I think, to Feast and Tecton, is this terminology we call on-demand transformations. And I think that unlocks a lot of really cool use cases. So please get to the third module. Yes. My intention is, if we don't have time to kind of get through it in the hour, I'll just continue working and then post the recording so that people can look at it after the fact. You're also welcome to stay on to ask questions. Cool. So let's dive right in. So so one thing the first kind of situation, our general goal here is, as I said, to build a platform for data scientists and engineers to share features, specifically for training offline models and kind of serving offline models. The data is kind of hand-wavy. I simplified the data to make it easy to explain. But generally, kind of the thought is that you're going to have data in a combination of data warehouses or maybe data lakes as well. In this module, we're going to focus on if your data is in S3. So let me kind of first. So Feast has a bunch of modules. In this case, I'm going to install the AWS dependency for Feast right here. And while that's going, so there's some dummy data here, and there's actually included Jupyter Notebook as well that you can kind of just basically just paste this. And you can see that roughly if you run it, you'll see what we're working with. So in short, this is some driver stats information. Roughly, we're working with like a imagine like a ride sharing app, you have a bunch of driver information, the logging in, some some miles are driving, and there's kind of that's being published on an hourly basis. And so that's kind of roughly what this is showcasing. Nothing too fancy. Yeah, exactly. This is what I call over here. The driver here is what we refer to as the entity, and that's kind of basically the primary key of this table. The event timestamp is also when the event happened, and it's really important that we have this time series data so that when we're constructing the historical features for training data, we can figure out like, given your label and when you want to construct this and predict something for the label, that we have all the right features in the right times, right? So yeah, I'm gonna super quickly just bulldoze through these concepts. Don't worry too much about them. We're gonna revisit them as we go through the examples. Data sources, pretty straightforward, I think. Basically, where your raw data is sitting. Maybe it's not even raw data. Maybe you have some upstream transformations that are happening, right? Entities we already talked about. That's the driver situation. Feature view is probably the most interesting kind of the core concept that Feast really pushes through, and I'll dive into this a little bit more later. But roughly, it corresponds to logical groupings of features and transformations based off of the data source, right? And these feature views are reused by data scientists, reused by engineers, and they're registered from your local feature repository with Feast. One thing, module 2 is going to call this on-demand feature view. So feature views, as I mentioned, like it's not just kind of a view over your data. It also actually supports, this is the final schema for features after you run transformations. So we're going to run into that in module 2. Feature service, that's basically Feast's concept of a model version. So you can track all the features that go into this feature service, and that's gonna allow you to figure out like to iterate on features, to figure out what features are in prod. So we'll drive into that later as well. The registry is really kind of the central metadata store that we have. So it's kind of just it's where users will be pulling from. It's what you will be setting up if you're on the platform team, and any kind of model service or feature service will be pulling from this as well to understand, to figure out like what features are available for you. And the provider, so this is mostly an interface that Feast provides that lets you kind of customize a plug and play kind of various components of Feast. For the most part, what a provider does, if you specify a built-in one, is just ensures that your registry is stored in S3. So the registry is actually just a file by default, and we store it in S3 so that different servers and users can connect to that file, pull it down, and see what's in your feature repository. It also specifies some default offline online stores. So kind of I'll get into that, and you can obviously override those stores however you want. So an offline store, this in Feast is typically a data warehouse, and it's what we will use to execute a lot of these kind of large joins and in the future transformations. The online store is not relevant in this module, but it is a low latency data store that we use to store pre-computed features, and that's going to be what you use for real-time inference. It also is where, if you want to ingest streaming features, it'll go straight into the online store. And yeah, so this feature view, this is just an example of what a feature view looks like. This is actually one of the exact feature views that are in this module 0. So it has, as you can see, kind of a name, description, entities. There's a question from Abe. If you use GCP, will you work for GCS? The answer is yes. So there's a GCP provider that you can install that will load your registry into GCS, and you can work with BigQuery, for example, as well. Yeah, so you can see that there's a schema that corresponds in this feature view to actually just what's in the raw data source. There is, and that's configured by the source. You can see that there's also this tags information, owner information, and this is all, not really useful if you want to reuse these features and share these features. People can then figure out like, who is using what, is this in staging, prod, etc. So yeah, this is kind of just calling it the same thing. One thing that's important to note here is that feature views represent groups of features that logically are physically co-located. So in the offline store, they're often coming from the same, say, BigQuery table or data set, right? And then the online store, what Feast will do for you is actually store it all into a single, say, Redis hash or Dynamo table. So it's meant for efficient kind of writes and reads. And yeah, so let's kind of keep going. So generally, when I think of Feast, there's really three groups of users that are all players in Feast. There's kind of the ML platform team that's trying to set up, the overall end-to-end data pipelines and feature repository CI/CD. There are the ML engineers who are working with the data scientists to run batch inference, to maybe even think about distributed training for data scientists. And then the data scientists, of course, are pulling from their data sources to build these models and iterate, right? So first, I'm going to focus on the ML platform team. So so as I mentioned, we're going to be using S3 to store our registry. So let me kind of just go into, there is a, where am I? Come on. So there is an infra, and in here we have some Terraform projects to help you set up the S3 bucket. So init. And yeah, you can see that all that this is going to do is basically create an S3 bucket and actually upload some test data. So that's kind of the test data we just looked at in the notebook. So Terraform apply. What I'll do is I'll actually prompt you for a unique project identifier to basically namespace the bucket. So I'm just going to type like Danny. And yes, cool. And then, while that's going, the first thing that the platform team needs to do is set up a feature repository. And that's the key thing here is this feature story YAML. So what is that exactly? So we can take a look at that. So I think I pasted it here. Yeah, so if you look at the feature story YAML, there's a bunch of line items here that correspond to some of the concepts I just talked about, right? There's a couple of new things here. So the project is is basically a namespace. So it's we use it to isolate infrastructure. We will, if you have every Feast object, like a feature view, is all tied to a project. And so when you fetch features, you can only fetch from the same project. The provider is what I described before. It defines the registry location by default, and also, can it live in S3, can it live in GCS, and also some defaults for the offline online stores. And that's and then you can see that the online store over here, as I mentioned, we set to null because we're going to be working with a batch only use case for now. You will see in the next modules where we do start specifying this online store. And finally, in this case, we're using the file offline store, which is mostly meant for quick debugging. In practice, we do recommend that you use a kind of a data warehouse or Spark, for example, because that's going to let you do a lot more scalable joins and kind of generally be more efficient and whatnot. So, and then there is kind of flags at the very end. This is kind of a soon to be deprecated way of enabling experimental features. In the future, we'll just be kind of showing you warning signals as you use it, so that you don't have to kind of explicitly specify in all your feature story YAML files. So yeah, kind of I threw some random kind of FAQs here. It's actually kind of interesting to look at one of the configs. So each offline store, for example, has some unique configuration, and you can actually look at that on the reference. So in this case, you can see that if you want to use Snowflake as an offline store, you can override it in the feature story YAML and specify, for example, your user credentials. And each offline store has its own unique configurations. This is kind of what I already described before. I think the key thing to remember here is that one common confusion point of people who first start with Feast is like, if you want low latency access to any feature, you should be using the online store for inference. And that's actually not what I would recommend. I would actually recommend, if you're doing batch scoring, then you actually use get historical features, because that's going to leverage your data warehouse and be able to very efficiently generate your entire set of features that you need for inference. And similarly, kind of online stores also have their own configurations. And then finally, there's also, if a lot of users do use this, you can plug every single component in Feast, so like the offline store where you store your registry, where you store your online store, or even the entire provider logic of how you materialize features. That is all customizable through the provider interface. And you can see here's an example of how you would specify a custom offline store. Cool. So let's go ahead and run Feast plan. So Feast plan is going to be, for those of you who are familiar with Terraform, it's very similar to that. So it's going to be a And for those of you who are following along, if you create your bucket, you'll have to actually change a couple of locations where I refer to the bucket. So you'll see that I think I called out, yeah, so this data sources.py, there is a reference specifically to the bucket that it was created. And so you should insert that there. And also in the feature story YAML, you got to replace that as well. So yeah, you can see that I ran feast plan, and you can see that there's a driver entity that got created, driver alloy stats. This is all a dry run. It kind of gives you a preview, and we'll see how this is interesting from a CI/CD perspective, because that's we can kind of make sure that we're not going to be destroying features that are used in production, for example. So let's go ahead and actually run feast apply, which will commit this to that remote registry in S3. Which feast will automatically create for you in the S3 bucket that you specify in the feature story YAML. Cool. So yeah, let's kind of verify real quick that these features are registered. So feast provides a very large CLI. It's generally kind of, I would use it mainly for just debugging purposes. The way that I would, looks like there's a question.
Yeah, I have a quick question. So when you say online stores, you just mean it's just serving online, right? But what about computing online, like computing the clicks over the past, let's say 3 hours or 3 days? So all those kinds of online computation, like does Feast support that, or that's not part of the discussion?
That's gonna be more focused on module 1 and module 2. But in short, Feast supports some kinds of transformations, and one of the top roadmap items that we're working on right now is actually you include streaming transformations and aggregations. Right now, it actually kind of requires that you push some aggregates into. This meeting will be recorded, and so you will be able to access it afterwards. We'll be publishing it online.
Cool.
So the online store is in short kind of just a raw data store. Feast will handle other transformations, and then those features will either kind of be stored, the values will be stored in the online store, or in the case of the on-demand feature views, those will actually be computed after you read from the online store. Okay, so Feast does come with an experimental web UI. So this is something we can take a quick look. Let me just make sure that cool. So yeah, you can see that we do have an S3 bucket, the Feast Workshop Danny, and you can see that this has successfully kind of updated that PowerK file. So yeah, if I run Feast UI, what that's going to do is it's going to spin up a local server, and then you can, and underneath the hood is actually going to be regularly pinging this registry file in S3, and so it's going to display for you basically all your different objects and what does it look like, and you configure it. This is what I would imagine that people would actually deploy a web UI internally so that data scientists, for example, can access it. So let's take a look at that. So yeah, I would encourage you to kind of play around with this. For now, I think the most important thing is that you can see that there are indeed kind of features that are registered, and kind of you can see that there's some metadata attached to this, and you can see that it actually does refer to this S3 bucket that we've uploaded. Cool. So yeah, here's some kind of sample images. So yeah, so of course the next step is for you to actually add your feature repo to version control. And this is something that we recommend because ultimately you want to run some CI/CD pipeline, you want to version on your features over time, and we do kind of recommend you have a pull request centered flow. So and what that's going to do is, so to quickly answer kind of Perry's question of like, why don't we use SQLite for the demo? It's actually because we want to focus on CI/CD, and what we want is actually a GitHub action to be running feast plan on your behalf, pulling from that remote registry, and also then running feast apply when the pull request is merged in. And so that's going to basically enable, once you merge in the pull request, that's going to directly apply your feature views, change the registry, and potentially also change kind of any infrastructure that we need to serve features online. So that's kind of roughly what I just explained over here. So kind of why would you want to run feast plan? We recommend that as part of your CI pipeline. So basically, when you get a PR that comes in, we recommend you automatically run feast plan. So this is an already kind of existing GitHub workflow that I've already kind of thrown into this repo. So you can see that roughly it's setting up the AWS credentials. And so in your so later in this module, as an optional task, I would actually ask you to in your fork of the repo upload your own kind of AWS credentials, and so you can submit a pull request and see this in action. And what it's going to do is actually going to paste a comment in the PR, so you can see in this image that I added a new pull request that's in this repo itself, and it kind of basically calls out that okay, there is a new feature view that's added. So, and then the second kind of GitHub action is doing exactly what I just described, which is once you've pushed something to the main branch or merged the pull request, it's going to run feast apply automatically for you. So. There is a question from Adam. So do you typically recommend people store their, I'm going to just paste that into the main Slack as well. Do you recommend people store their feature definitions or transformations for bash features, or just use feast as an API for accessing and joining features? So right now it's kind of hard to store transformations fully in feast. I do recommend it though. But we'll kind of get to that in a little bit. The key kind of benefit to storing them in here is that you can actually tie them all together. So if you have, for example, some batch transformations and some other things that are stream transformations, they often refer to the same set of features that you want to access. Just in one case, maybe at training time for the data scientist, in the other case, for online inference, right? So I do recommend that you store them, and that's also going to let you unify your data engineering pipelines. And so if you just store the definitions in feast, then what you might see is people can conform to the same spec, the same schema, but have different divergent upstream pipelines that generate the same features, right? And so that's not kind of what you want. So here kind of what I call out here is I wouldn't do this in this workshop, but I would recommend that you lock down your registry so that you don't have data scientists just cloning your repo, changing the definitions and running feast apply, and that can immediately impact your overall infrastructure and also production features that that you may be depending on. So I'm not going to dive into this. The main thing is kind of there is a common path that people care about, which is what about setting up like dev or staging environments, and that's something that we do recommend that you set up separate folders, so you can have like a staging folder with all your features for there and your feature store YAML that points to, say, a dev registry, and then you have a production one that points to the production registry. And so the staging kind of situation, also it doesn't call it the dev mode, so you can, what I would recommend if you're a data scientist iterating, as we see later on, is to actually have your local, have a local registry that you can iterate on in your local environment, and then publish that into in a pull request. So that's kind of the first section where we covered, how would you set up this feature repo so that data scientists and ML engineers can collaborate on what features will make it into production. The next section is kind of what if you're an ML engineer, like how do you kind of actually deal with batch predictions? So the key API here that's important is get historical features. So Feast exposes on the SDK a feature store object, and within that you can call get historical features. So that's going to retrieve features from all your different data sources by referencing your feature views, and it's going to do the point in time joins for you. It's going to ensure that that you're avoiding data leakage, and also it's going to kind of do some basic validation for you as well. So for batch scoring, this is kind of a current limitation of Feast, is that you can't just say like, get me all the features at the current time. So you can see that what I end up doing in this workshop is to do I add this event timestamp, I hard code it to now, and then that way I then pass it historical features, and then kind of we'll be able to pull from, say, like BigQuery or Redshift or Snowflake, and generate all your features, the latest features for your given unique entities that you need to score. So that's kind of what's happening in the, you can see this happen in kind of the client and client no YAML directors, and we'll kind of get to that in a little bit too. So yeah, so feature service, you'll notice that over here, it's actually using a feature service. So it's calling features equals store.get features service. So one way that people commonly use this method is initially you can actually directly reference features. So you can say like, give me this feature view colon this feature name. But what I would recommend is as soon as you kind of move into any level of like production readiness, I would recommend you actually use a feature service. And so this is kind of the way to register within Feast, like, hey, I have a given model version. So a data scientist can then use this to recall, like, for a given model version, what are the features and specific versions of those features used for that, right? And then when you're ready to productionize, then the engineers can just call that same feature service at serving time. And they don't need to kind of figure out where the features are coming from. They can just pull it out. It'll also kind of enforce, like, if you have other dependencies, they know what dependencies they need to pull in to kind of generate those features. And then kind of the third point is really important as well. They give visibility into what features are dependent on in production. So what you can do, and what I've seen Feast community users do, is set up a pipeline where if you have any changes to a feature view that's encoded in a feature service, you prevent that PR from merging in. Like that implies that if you merge that in, then that will negatively impact some sort of production service that's already running, right? So that's why I recommend feature service. So just to kind of quickly read this question. At this point in the workshop, when you're calling store.get historical features, is all the logic running locally? So we're using the file offline store. And so what that is going to do is actually use Dask underneath the hood and do that all locally. But it will at least read from S3 in the file store. So let me kind of pull up the actual features. So you can see that the data source that we're using here is using a file source that's pointing to an S3 bucket. And then there's an S3 endpoint because by default, Dask relies on this S3FS kind of package, which defaults to US East. So kind of we have this endpoint override to help you override that. But the answer is, yeah, for the most part, this join is happening locally, but the features are all stored in S3. So now you can go into kind of the module 0 client and change the feature store YAML to user bucket. And if you run it, so kind of this is, as you can see, pretty much exactly what I just showed you, where it kind of hard codes that now for the mn timestamp and runs that. So you can see, let me just kind of quickly create a new, client. So that's going to just kind of run this and give me, hopefully, why is it not running? There you go. So took a little time because I had to go through S3 back, I guess, but it gets you kind of the features. And I guess you have to take my word that they are point in time correct, but it's fetching from one file in this case, so not too hard. So that's kind of one way to do it. So what this relies on is that you actually have, as you can see here, the client only needs a feature store YAML, which references the project, has a provider, has kind of the online offline store, and most importantly, has a pointer to what your registry is. And so then, so what it doesn't need, for example, is like all the rest of your feature definitions. There is another way, which is also quite common, that people will do is instead of trying to package the feature store YAML, you can initialize it directly in Python. And so this is useful if you just to simplify general like packaging for all the different places that you might want to use Feast. So here you can see that this is configured in this client no YAML, so you can see that all it has is this test fetch. And it's actually initializing the registry. So all this stuff corresponds directly to what's in feature store YAML, and it corresponds to a pydantic model. So you can look at the on the Feast documentation for like what is in the file offline store, what configuration is there, what is, if you want to say like a random online store, like what fields can you specify for Redis, for example, and we'll dive into that later as well. So yeah, you can, I can verify for you as well that if I run this, it'll do the same thing. And so yeah, what this is happening right now is it's actually calling this to data frame method. So really what is the output of this get historical features method is actually a retrieval job object. So this is kind of a lazy execution object. it stores kind of, here's some sort of query that you need to run for data warehouses, like a SQL query, for example, and then it'll run that when you call some method. So if you call to data frame, that's going to pull that all into memory. That obviously will not scale if you have very large data sets. So what the retrieval job interface will do is every offline store has its own extension to retrieval job that lets you flush it out into some other kind of place. So it could be like to S3, it could be to GCS, or you could also kind of generally flush it to the data warehouse itself again. And so this is kind of useful. You can also, one other way I've seen people do this is the platform team will regularly generate a set of canonical features for all entities, and the data scientists can kind of pull from that. And knowing that they don't need to do any of this stuff, they can just directly read from this data warehouse table, right? So you can see that it is using to BigQuery. And I think what it'll give you is actually kind of the path to like data set that you actually kind of uploaded it to. And kind of what I say here is like you can continue after that with like your distributed training if you wanted to go there, or actually kind of run batch predictions directly, depending on whatever your task is. Just do a quick time check. So we are 30 minutes in. So let me kind of speed up a little bit. So yeah, kind of data scientists, I think this is like the really critical user, right? These are the users. Generally, the people who come to Feast are typically platform engineers, but they're trying to sell to these data scientists, right? So like, would a data scientist want to use this? One really big benefit is, we've all heard the spiel of like how it takes forever to productionize the model, but it's easy to build the model. One of the big reasons is that there's this kind of wall that you cross where you throw a feature that you define, and then some engineer has to redefine that. So one thing is like, if you've already defined features for other teams, then you can already just use that out of the box and just know that that's going to be ready when the engineer needs to kind of come in. You can kind of look at other features, other models, and what features they use. We've heard this as well. Basically, you would go to a feature service that you're interested in and kind of go backwards, maybe, for example, within the web UI to figure out what feature views or data sources you can use, right? As I already mentioned, you can organize experiments. And then kind of, one really big reason in the future, in the upcoming modules, is you can directly author features and transformations that will be used directly at serving time. So it kind of basically is, data scientists can now help the ML engineers directly author those features that will be used. So that the ML engineer doesn't need to think about, oh, where do I pull data to get this? Or like, how do I kind of change my transformation to work in online? So yeah, this is kind of, I'm just going to jump over this because this is about the same as what we already talked about. And so because we're running a little short on time, I'm not going to go through this sample PR, but you can, I would definitely highly encourage you to go through this afterwards and, actually do a change. So maybe like change a field in a feature view or change some metadata, and then kind of make a PR, and you can see how it'll kind of automatically run Feast plan, give you that message. You can run Feast apply, and then verify, for example, in the UI that it actually has changed and updated to reflect your new kind of feature views. So yeah, so that's kind of module 0. The other workshop, will they be shared later? I'm assuming that's referring to the Ray workshop that's happening. So yes, that should also be shared as well. Cool. So I guess before I go any further, any kind of like questions, things that I covered too quickly before I jump further? Can I talk about best practices around CI/CD PR workflow a little bit more? Sure. So, right now, I guess like I'm not, maybe could you elaborate a little bit more on, you would like to see the API demo? Okay, cool. Let us kind of just go ahead and do that then. So I'm already kind of in this. So I'm in the main branch. Let me kind of create a new branch. So let me kind of go into the features themselves. And as I mentioned, I can maybe like change. So like say I can change like the owner to like test. Maybe I'll change the description a little bit. From Danny, and then maybe I don't actually care about this kind of whatever this feature is. So let me remove that. This is kind of typically what I would not recommend because you have a feature service that you're depending on. And I can also create kind of a new feature view as well. That maybe kind of has like test2 or something like that. So it's basically the same thing, just with a different owner. Cool. So I made a bunch of changes now. Let me kind of let me commit this. Let me sign this. Cool. So let me push that up into a branch. Oh, come on. Cool. So now I have an actual branch in the the workshop that you're working with right now, and that's going to, so you can see that now if I make a pull request for this, you'll see that I don't know why it says it's not signed, but there should be this feast plan workflow. So this is kind of exactly what I had described, and it's going to run. Oh, not that. What happened to the check? So yeah, you can see that it is going through everything. So it's installing Feast, it's running Feast plan. It's going to kind of generate that that comment within this directly. So then, to get to Julian's point about like what are best practices around this, I don't have like super concrete thoughts here. Generally, I mean, what I would say is that you should have a feature. You should center everything around feature services and assume. What I would assume is that anything that's in a feature service is already in production. You could maybe play around with that a little bit and say like you could include a tag that you're requiring. What is causing this to fail? So that is yes. So this is a kind of a validation error, and that's good. That's something that's broken, I guess. You do need to have unique names. Let me kind of push that. Oh. So what I was saying was yeah, you could optionally also take like your feature service itself, and so every object I think has tags that you can apply to it. So yeah, there are tags. So yeah, one thing that you could do maybe is also like say for any feature services with a tag of like production is true. You can throw like a workflow that just blocks any of these PRs, or it's just like, hey, this is gonna be bad, right? So that's something that I think could be really useful here. But generally, like assume that your GitHub, your CI/CD pipeline is going to be the one that the workflow that actually impacts your production services. Everything else that you do should just be kind of a local dev environment. So in this case, I guess this is not a, I can definitely kind of polish this description a little bit more, but you can see that there is kind of some rough output here. If I had a little bit more time, let me, I'll clean up this bot as well. Can I elaborate on the concept of entity? Yeah, so what is an entity? So mostly this refers to kind of what you would think of as like a primary key for a database. So like a driver in this case, or maybe if you're working with like a recommender system, you might be in e-commerce, maybe you have like a person, like a buyer, a shopper of sorts, and maybe you have like an item. So those are all entities. How Feast will use this is like an entity is what you'll be joining things together on. So like if you have multiple different data sources that all rely on driver, then you can have different, say like join keys, like the different columns map to the same entity, and Feast can help you join all this together into the same data frame for a training set. Not sure. Yeah, so I guess in the interest of time, let me just paste all your questions into the Slack, and we'll have some other kind of Feast folks answer these questions. I do want to get to the second module as well. And there are some kind of like FAQs that you can read through as well. So the second module is where we're going to dive into the stream ingestion. So this diagram can be a little bit overwhelming, but you can see kind of roughly what's going to happen. So you have some batch sources, so kind of like the file source that we had before. You might have a Kafka topic or some other stream source that that you're going to kind of transform with Spark, and then Feast can kind of ingest and unify both of those. And then that's going to kind of come out on the other end, either through get historical features if you want to use it for batch scoring and training, or get online features if you want to use it for serving, right? So so let me kind of like go back over to actually I could just say here, oh, module 1. So okay, so yeah, in this case we're going to be using Spark and Redis, so there's additional dependencies we got to pull in. So let me quickly install that. And what I've done here is I've actually changed the original kind of stats. So you can see that the big difference here is that there's actually these two final columns. So some sort of like how many miles did you drive in this kind of I guess in this case it's in an hour because it's hourly stats, and then kind of some sort of aggregation that's happening on like, you know, how many miles did you drive that day, right? So that's something that we've already pre-computed in some batch flow, and we're going to be exploring like how do you kind of generate that on the stream side and how do you kind of unify those into a feature service, right? If you look at the feature story YAML, you can see that some things have changed as well. So the most important change here, I think, is that we've added this online store. So you see that we specified before it was null, we've added now like Redis, and kind of just for simplicity, we have a connection string. So there's other kind of options here as well. And also if you want to deploy to a Redis cluster instead of a Redis node, then you can specify the Redis cluster type and specify, the different kind of bootstrap nodes that you need and any authentication. So that all is kind of configured by the, in this case, like a Redis online store config that you can look up and specify in feature story YAML. And so yeah, we're under the hood using Redis Pi, so that means it'll also work well with any hosted Redis instances like Elasticache. So okay, so and then if you look at this module, so what we've done already is I already kind of spun up a kind of wrote a Docker Compose. So what that's going to do is kind of give us all the infrastructure we need. So it's going to simulate a stream. So I have a kind of a dummy script that will read from actually our existing driver stats Parquet file and generate basically like generate new timestamps and emit them back. So you can see that in the actual Python file. And then it also deploys an instance of Redis, and also kind of, I'll get more to this, but it actually deploys a couple of Feast services as well. So it deploys a push server and a feature server. So this is probably something that you will be doing as well. So, as I mentioned, like you have multiple ways of defining these. You could either copy directly over your feature story YAML, or you could kind of initialize that in a Pythonic way, right, with that repo config object. But in this case, I've actually just added the feature story YAML. So you can see kind of like this is, what I've described, like there's a feature server, there's a push server, and it's kind of, we're automatically running this, this Kafka demo kind of Python script. So, yeah, and the, what these kind of servers are using is actually this feast CLI command called feast serve. So if I wanted to, I could actually also go to, basically like the feature repo and apply it. So let me actually, first, before I do anything, kind of instantiate everything. So that's going to spin up all the services that we need. What am I using? That was a direct message I just got. This is VS Code. So I actually referenced that in the prerequisites as well. So yeah, let me go to module 1. So I already have everything running. Let me go into, I guess the next step actually is I can go directly into the Jupyter Notebook, but I can show you that if I wanted to serve something as well on my local host, I could do, so this is where all my features are. I can then do feast serve, basically something like that. And that can, that'll spin up a server that I can then kind of send HTTP requests to directly fetch features. But anyways, so let's go directly to the notebook, which is kind of the, actually before we go to that, I want to explain a little bit some concepts that we'll be using in the notebook. So there is a kind of a concept of a push source that we'll be using in the feature views. And kind of, let me kind of get back to like why might you even want to register these streaming features in Feast. To me, one of the biggest benefits here, aside from like the ability to reuse pipelines and transformations, is that a data scientist has this disconnect, right? So like they're likely to just read from the batch sources, do some feature engineering, And then maybe they'll hand that over to an engineer to productionize, and then they'll realize that maybe model performance is not as good as what they wanted, right? And a key reason there is maybe you have pipeline delays or whatever, and like the engineer didn't actually get you super fresh data. And so now what this enables somebody to do is a data scientist can directly rely on a feature view that configures a stream source or a push source, and then that will ensure that when an engineer needs to use it, they're kind of decoupled away from the need to generate those fresh features. Some other team that's kind of already working with those Kafka topics that are publishing to a topic, they are kind of the ones who are in charge of generating those fresh features, right? So this I think can reduce training serving skew in many situations. So you can see that what's happening here is that we configure a push source, and roughly what this is going to do is it will say any feature view that depends on it. That's going to control the actual schema of this, and define. But basically, if you have the ability to push data directly into the online store that matches any feature, like basically this feature view. So in this case, we'll be expecting roughly a daily models driven kind of feature, as well as an event timestamp and create timestamp, because it's depending on the batch source. And that's going to be kind of what we use in the online serving flow, and the offline serving flow, it's going to use this batch source directly. So I think I just answered that question, which is that a push source does rely on a batch source. So today, I think the assumption is that you already have some sort of pipeline that's kind of streaming these into, and what I see most often is you write them to, say, a data lake. You have some ETL process that generates the actual batch source, and that's kind of what you depend on. One thing that we are considering and people have asked for is, can we basically implement a Kappa architecture for you so that if you push data, that also pushes directly to an offline store, and that's something that we're considering. So if you're interested, let me know. That's something I'm very kind of interested to talk to people about. And then just a quick shout out, Feast is actively working on a stream feature view concept as well, and so that's going to let you actually specify the direct, say like PySpark transformations that you need, or Spark streaming transformations that you need to share that between features as well. So that will mean that the engineer doesn't need to actually figure out like, let me make sure the engineer doesn't need to figure out like, okay, all these port sources, do they actually have reliable kind of separate pipelines that are pushing data into this schema format? You can just rely on like the engineer could just look at like, okay, here are the stream feature views I'm depending on that are ingesting from, say, a Kafka topic, and just make sure that those jobs are still running, right? Cool. So let's kind of jump into this notebook, which is going to actually kind of do a bunch of the stuff for us. So I already kind of call out like this is the overall architecture that we're working with. So yeah, first, I'm gonna start up a Spark session within this notebook. Obviously, this is not something that you would do in production. You would actually have a separate Spark cluster. But there's nothing kind of stopping you from doing that here. This is just kind of to make it easy for you to verify. And then I forget if I've already run feast apply locally, but I haven't. So in this case, it's now registered all these features. And now the actual features for object. So yeah, I guess you can actually run through this yourself. So I'm not going to rerun all this. Actually, I'll just rerun everything. So this is just to kind of verify quickly that the features do exist in the offline store. This is kind of what I was referring to before, by the way, which is like, you don't have to use feature services to request. You can also use a combination of like feature view name colon the feature, and that's going to get you just those features. We'll join, so you can see that kind of it has given me these feature values directly by reading from the file source. And then there's this concept of materialization. So what this is going to do is Feast will read the latest values for each entity, each unique entity, and then kind of load that into the online store. So that's kind of, if you think about a Lambda architecture, right, where you have batch data that you consider to be more correct, that's going to load that batch data, get some pre-computed features, and load that into an online store, so that at certain time you can just read that in low latency. So that's kind of what this is doing. Materials incremental in particular is Feast actually manages all these intervals, so it will store like if I've materialized until now and I wait another hour later, materialize incremental will know that actually I've already run materialization an hour ago. It'll only process the new data after that time. And so, another kind of quick thing to call out here is like, because you do have delays, I would actually recommend that you maybe like actually structure staggered kind of materialized incrementals, and instead of using materialized incremental, using storing your own kind of intervals yourself, and maybe having like a start and end time that you construct to address like out of order or just like a late events. So there's a couple different ways that you can retrieve. So this is kind of the one of the ways. So if you have, this is probably the most popular way to do this, which is you already have some Python service, maybe like you have a Flask app, and you will instantiate that feature store object and call directly get online features. And so, so this is actually, I forgot to run materialization, I think. So that means that the features are not there. You can see that, in that case, like it actually gave me none. And now that if I run it now, it will give me kind of a certain value. So that's kind of what that's about. The other way is to actually directly, you don't want to instantiate a feature store object at all. And so in this case, that's where that feature server comes in that we've instantiated from Docker Compose, right? Which uses feast serve. And that's going to let you kind of hit directly an HTTP endpoint, which is this get online features endpoint. And you'll see that kind of you have to craft this other JSON object that you pass in to get the features. And it comes back in a different mode as well. So you can see that kind of it shows you what features are present and what the values are, etc. So this is kind of a situation where maybe if you don't have a feature value, instead of the above situation where it says like none, I would say like the value is just not present, right? Cool. And then kind of the next section, just a quick time check. So we have another 7 minutes left. I'm trying to speed through this. So this is kind of an actual kind of stream transformation. One thing to call out here is that Feast is not actually managing this transformation. We expect you to have your own upstream transformation that's happening, and then what users will do is flush it out at a certain periodically to Feast through this push source. So kind of the magic is really happening here. But in this case, kind of what is happening in this, it's computing that daily miles driven by kind of doing a sliding window over a given day, and processing every 30 seconds and kind of processing a batch. And so I kind of made it a little bit more complicated because theoretically you could have like multiple windows in the same period. Certainly in our test situation, we're actually just writing directly from or emitting events from the driver stats per K, just with newer timestamps. It's definitely going to see multiple windows. So this kind of compacts that to the latest. But the key thing really is just that we are calling this push event. And one thing that's kind of worth calling out here is as well as like a Spark will kind of give you this end as the default column name. We're expecting kind of a consistent schema as what you have in batch. And so if you don't have this event timestamp rename, it's going to throw you an error when you push it in. So you can see that kind of we're processing these windows and it's going to be pushing data in. And then while we do that, just wanted to kind of check so this is the old value for the same driver, and we'll basically be able to see that this value, daily miles driven, has actually updated in response to this push source. So yeah, you can see that it used to be like 300 something, now it's 240 something. And then I'm not going to run this, but this is kind of the equivalent of like how would you do it if you didn't want to instantiate a store. So this is where you could use that push server. And that's kind of very similar to what we already saw in the past, right? Cool. So yeah, thank you, Steph, for joining. And we'll definitely kind of feel free to follow up afterwards. I'll also kind of share the recording afterwards as well. Cool. So that is kind of this notebook. Now I'm going to call out some, so materialization I think is actually a really interesting situation. So, how do you actually deal with it? Most users that we see will be scheduling it at a fixed cadence. And so and this kind of just depends on how fresh you need your features. Maybe you want to schedule like materialize every single hour, every day, whatever you need to kind of do to ensure fresh features, right? And obviously at a certain point, it becomes, you can't materialize that frequently because just you're not going to outpace the data freshness itself, the data pipeline delays. And so that's going to be where you need that stream source that you push into the online store. But yeah, it could be as simple as using a cron job. A lot of users say that they want to integrate with Airflow, in which case you can do something very similar to what we already described here, right? So there's kind of two different ways. This is probably the simpler way, which is kind of directly instantiating the feature store object and passing that into a Python operator. And then you can alternatively use that CLI command as well if you package the feature store YAML into your image, right? And this is useful. There's kind of FAQ question that you could read into, which is like, what happens if materialization takes too long, or how do you scale it up? And there's a bunch of strategies that you can employ, but that's actually also an active area of investigation and kind of improvements. We're trying to improve on that right now. So we'll be happy to collaborate with you guys on that. And then one kind of final thing is that I guess these feature servers and push servers, you may be wondering, like, how does this interact with that whole CI/CD thing? Because the registry can be changing underneath the hood, right? And so what these servers under the hood are actually going to be caching the registry and then kind of fetching every once in a while. So the default setting is it's going to fetch every 10 minutes. What I've done here to kind of make it more responsive is I've specified a cache TTL of 5 seconds. And so that's going to make these servers, this is kind of what's bundled into the into the feature servers themselves. So it's going to be much more responsive. And yeah, so that's kind of this. We have just 2 minutes left, technically, but I'm just going to keep going to kind of get to module 2 as well. So that we can kind of dive through. Actually, let me kind of quickly just show you, kind of go back to that first image. So now you can see kind of, zooming out a little bit, like this is what we've done, right? So we've specified we have single feature view with a push source, which corresponds to kind of the streaming source, and then also a batch source, which you're going to be using in get historical features. And so that's going to basically this batch source to the push source is going to be used like get historical features, right? Then we have this kind of regularly scheduled materialization flow that's going to move the latest values from batch into the online store. But you'll kind of be able to combine that with that that transform streaming feature into the same online store, so you have fresher features, right? And that's all going to be, you can push into that either through the SDK or through using an actual HTTP endpoint. I think that we also have some of our feature servers have gRPC endpoints, some of them don't. You kind of have to double check on that afterwards. And then kind of that powers kind of real-time model serving if you call it get online features. Cool. So that, I don't want to kind of hold you guys here. Anybody who's still interested, please stay on. And I'm going to go into now module 2, which is going to focus on like what is the on-demand transformation. So how do I preview you? Cool. So on-demand transformations, what are they? They are transformations that execute on the fly. So this is really interesting because there's a bunch of features that you need request data for, and so we're going to dive into what that actually means. But this also means that you can perform some last mile transformations that happen, regardless of whether it came from batch or streaming. So in this case, what I'm going to use is actually I'm going to use the geohashing. So we're going to be working with some location data now. And so let me kind of go into that module. And I'm going to install, so I've already installed pod geohash. So what I've done with this is I basically took the previous data set and I ran another kind of random generator for latitude and longitudes. So you can see that now there's a lat and long column, right? And so what we're going to do is, this is like pretty common, which is you want to construct geo features based off of this, maybe using a geohash and actually generating features downstream, right? And why on-demand feature views are interesting here is that at request time, you don't have access to a geohash. You have access to a lat and long or longitude, right? And so if a data scientist naively just uses geohash and the offline training data, now the ML engineer needs to kind of figure out, oh, let me kind of do this transformation again and redefine this somehow, right? So this is going to let you kind of control that narrative more as a data scientist. So I added kind of a dummy example on-demand feature view here. So you can see that there is a request source and an on-demand feature view here. So this request source maps to, so you can imagine like maybe you're a user's requesting like give me some sort of recommendations, and in that in your app you're probably going to encode like what is their location, what time of the day was it, maybe if they've already, maybe it's a transaction, maybe it already has like a transaction amount as well, and you want to detect whether it's fraudulent, right? So that's going to be all encoded in the request source, and you can see that the on-demand feature view depends on this request source, but can combine that with other feature views. So that's kind of this driver hourly stats view. That's kind of one of the previous feature views that we had, and so you'll see that. So this is kind of what I explained over here. You can see that it actually can let you combine things. So this is really useful because there's a lot of features that you need to combine things, such as like, what if you have some average, say, transaction amount, right? And you want to see like, how does this current transaction amount compare to that average that you've already pre-computed? So that you can kind of use an on-demand feature view for, or maybe you want to do like a dot product between two embeddings, or in this case, I also kind of call it the geohash, right? So that the on-demand feature view is going to be, will let you combine multiple feature views with this request data to generate kind of an output data frame. You'll see that kind of the API here is to use a data frame, a pandas data frame. So Feast is going to, under the hood, construct the data frame for you and join together all the feature views that you need, and the request data to one big inputs data frame, and then you can reference that directly in this. So let me kind of just jump over this because I think I've already kind of talked about this a little bit. So yeah, kind of if you zoom back out a little bit, right, what this will mean is that, how does a data scientist use an on-demand feature view for training? They're going to likely have some sort of historical log of that user request data. And what I've seen most commonly is that's going to live where your labels are. So you'll have, like in the transaction, that fraud detection case, you're going to have a transaction as well as maybe some label that comes later on like, was that transaction fraudulent or not, right? And that's going to include, I would recommend you include a lot of features in that. But if not, you'll have some other log. At request time, right, what the ML engineer that's kind of deploying this feature in product will have to implement is basically, when they try to call a feature service that depends on on-demand feature view, it'll tell them like, hey, you need to have this request data available, and they will just kind of pass that into get online features. So we'll see that kind of happen later in this module. So yeah, in the interest of time, I'm not going to go through too much of the commands, but you can see that if I run feast apply, it is creating these actual on-demand feature views, and it actually creates a couple of them, which I'll kind of dive into. And materialization is important again because we're going to be relying on some of the pre-computed features for online serving, right? So actually, it is actually kind of interesting for me to do this, but you can see that now like if you use the Feast UI, now there's a lot more information there. So there's kind of you can see all the features that you depend on from different features sources. If I were to kind of nitpick on this UI, I probably would actually recommend that a feature service should also contain all the request data that's needed, so the ML engineer doesn't need to kind of go searching through everything and finding what they need to pass in, right? And the UI does also kind of specify what the transformation looks like. So yeah, so if you, so the actual notebook itself, recommend you actually go through that and run it. But what it's going to do is it's going to do exactly what I said, which is like run historical features on a given model service, feature service, and that's going to, here I kind of hack it a little bit to print it in the Jupyter notebook. But this is kind of what the features, what feature view is going to be run, right? And you can see that kind of roughly what you would expect is that there's a conv rate kind of field that's coming out, and that transformation is saying basically add these values. So you'll see that these actually do get concatenated or added on, so that you see like value 1 adds 1 2 3 4 to these, and then kind of value 2 adds 10 20 30 40 to kind of that second batch. And so that is how it works in the offline case. And then I have another example here of geohashes. And so actually, let me jump back to this outside here. This is kind of interesting because what this means is that you actually need to import a separate library to compute it, which is probably pretty common. And what that's just going to require you to do is that in the actual client that's using these transformations, get online features, get historical features, you're going to need to have the libraries installed, right? So that's actually a good reason to have a feature server, because that way the kind of downstream clients or your data scientists, if they're trying to test out get online features, they don't need to use install this locally. They can call directly, and that feature server has preloaded that dependency, so it can just compute for you what you need, right? So so yeah, if you kind of come back here, you can see that the let me see the yeah, actually let me see where the, so yeah, just taking a look at this transformation, what it's doing is it's taking every single input that you get in. So that input, which is coming from the request data, if you recall, has like a latitude and longitude. So that's going to come in, we run this geohash on that, and that's going to be the output feature for this geohash, right? But really what I kind of threw in here is this like kind of prefixes of it, and that's useful here because geohashes represent a kind of regions. And so what you'll see is that geohash 1, geohash 2, so really each like this S geohash represents a larger region that contains the S0 region. And so you can now kind of compare as categorical features all the different geohashes and kind of use that at serving time, right? In this case, kind of how this is working, because you'll notice that actually there's no request data being passed in. In this case, what it's doing is actually relying on a push source. And so this is actually fairly realistic here as well. You can imagine that and kind of coming back to our driver churn situation, drivers like to have an app that's asynchronously kind of pushing their location. So that may go into a topic, and that's going to be pushed into Feast in the online store. So we can just directly kind of read from that to generate kind of the feature view that will do the transformation. So if you look at the feature service v3, you can see that that's using this like location features from push, and that relies on this yeah, so this is the one that has a push source, so it has a lat and lon. So that's kind of how it's working underneath the hood. It's relying on that stream source for the latitude and longitude. So yeah, that's kind of roughly kind of my pitch for on-demand feature views as the so we'll definitely kind of, if you have further questions, definitely reach out to me. You're already in a Slack. Don't be a stranger. And let me just kind of jump back to this overall preview to make sure I didn't miss anything. So yeah, I do intend to kind of continue to add more modules to this, as just didn't have enough time to add everything. There is also kind of some data quality monitoring that's being built, and that there's actually a tutorial already for that. But yeah, we would expect that there's more to come here. And yeah, and as a final kind of reminder, I am also actively hiring, so please reach out to me if you're interested. Any kind of like last minute questions for those of you who are still on the line? Thank you for kind of being patient and kind of sticking with me to the very end. Where is the Slack? So the Slack is, let me just type it into the, so hopefully you're in the actual Slack channel itself, but there is a specific channel, which is hashtag apply-conference-workshop1-feast. So I would join that channel to kind of see what's happening here. The recording will be shared, so I'll definitely message out to kind of, I think I should be able to send an email out to all the respondents as well. But also I'll send it out into that Slack channel. There was a quick question on batch and stream transformations. How are they different from on-demand? And the key difference is basically when they happen. So stream transformations, batch transformations, that's going to happen before it makes it into the online store, right? But on-demand transformations happen afterwards. And one key thing it lets you do is also combine those pre-computed features with request data, right? And so that's going to be kind of one of the key differences between those two. And there's a lot of like really interesting use cases for, what I've seen is actually a lot of the most impactful features do actually come in the on-demand form instead of like a stream transformation feature. So cool. All right. Well, with that, I'm gonna end this so that you guys can all get on with your life. And this is a very, very long day, so really appreciate you stuck with me to the end. And yeah, I'll see you guys later.